Welcome toppers. So we are now going to start topic magnetic field due to a current element or Biot law. So in this topic we just start the section from the Biot law. So what is the Biot law? Biot law gives a relation between current and magnetic field. Understood? So what is this particular, like we are just going to understand what is the relation between current which is produced or induced because of the electricity and magnetic field. The Biot law asserts that magnetic field, which is represented as a small dB, due to an element dl. Element means a small section of that particular conductor carrying a steady current I at point P. As you can see over there, we have a P2 and P1 at a distance of a small r, okay, from the current carrying element. This gives dB is equals to mu naught by 4 pi I d cross L by R cube. Here both the things are different, as you can see over there. Like mu naught, this is a permeability of a free space. Again, this is a permeability of a free space. Clear? So this is that particular diagram, and all magnetic field that we know are due to the current or moving charges and due to intrinsic magnetic moment of the particle. So consider an infinitesimal element dl of the conductor, which is actually dl, and the magnetic field dB to this element to be determined at point P. So which is at the distance located r from it. Understood? Now let theta be the angle between dl and the displacement vector small r, which is the. So what we again, I'm just elaborating, this is a small element. This is particular point P1 where we have to calculate the magnetic field. This point P is located distance r. So from this distance r to that conductor, they will make an angle theta. I hope now this much is clear to you. So according to the Biot law, the magnitude of the magnetic field dB is directly proportional to the current I, and element length dl, that is a mod of a dl. So here we have not taken the direction, we just taken the element, conductor's element, and this will be inversely proportional to the square of a distance between them. So its direction, if I'm just try to calculate, so direction is perpendicular to the plane containing dl and r. That's why in an earlier case we are using dl cross r. Cross is for the direction which is I'm taking the perpendicular. So in the vector notation, we just write up there dB is directly proportional to the mod of a dl cross r. Again, cross means a particular value which is perpendicular to each other. So mu naught by, if we just remove this proportionality sign, so mu naught by 4 pi comes into the nature. dl cross r divided by r cube. Or if we just put dlr in, which is in a cross product, so that will become dlr sine theta. And we can easily divide that r to this r cube. And the final result which is a come, that is the dB is equals to mu naught by 4 pi, as you can see over there. dl sine theta by r square. How I will put just particular thing? Because we know the value mu naught by 4 pi, okay, this will become dl r, okay, sine theta divided by r cube. So we can divide this r to this r, and this formula will be comes into the nature. Mu naught 4 pi gives a value 10 to the power minus 7 Tesla meter per ampere. We call mu naught as a permeability of free space. Earlier we saw about the epsilon naught, if you remember. That value is 8.85 10 to the power minus 12 Coulomb square per Newton meter square. Again, this value gives the permittivity of free space, and this is what permeability. So this permeability comes when we are just studying the topic magnetic thing, and this permittivity comes when we study the topic electricity or electric thing. So dB will becomes mu naught by 4 pi I dl cross r by r cube. This is known as Biot law, and the direction is given by right hand screw rule. Similarities and difference between the Biot law and Coulombs law. So both are long range fields. Both obey the principle of a superposition. These are two similarities. If I'm just talking about that differences, so electrostatic field produces scalar. Magnetic field produced by vector source. The direction of the field is along the position vector. There is no angle of dependency. So if we just relate to the Biot law, so as we saw earlier, the electrostatic field produces by a scalar source, and this is a what? By a vector source. The direction of field along the position, and this will be perpendicular to the plane containing to the position vector and electric current. There is a no angle dependency such as, like if you remember the formula, students, so what is the Coulomb's law formula? That will becomes F is equals to 1 by 4 pi epsilon naught Q1 Q2 by R square. And here what we are using? B is equals to, or we can write up as a dB also, mu naught by 4 pi, again here I dl sine theta by r square. This is both the difference. As you can see here, there will be no angle, but there is an angle involved. It's also like a long range because this follows the inverse square law. This is also follows the inverse square law. Because of that, these both are long ranges. Clear? So they have a no angle dependency in the Coulomb's law, but they have angle dependency. So finally, a relation between mu naught, epsilon naught and C. That would be very simple definition, but that's important. So we can write up as a epsilon naught mu naught is equals to 4 pi epsilon naught mu naught by 4 pi. If we just put all these value together, we get the value of 1 by c square. So c square comes 1 by epsilon naught mu naught. We can easily write up this. C is equals to 1 by under root epsilon naught mu naught in the root section. So this is the final value. I hope you understand the topic till this much. So further, we start the topic like magnetic field on the axis of a circular current carrying loop. So as you can see, this is a current carrying loop in which the current I is flowing, and for the small element we have just taken the dI current. From the center of the circular particular conducting loop at the center at point B, we have to calculate the magnetic field, which is the P point is located at a distance small x. Capital R will be the radius of the circular loop, and R will be the point from this element to the point P. So let's begin the topic. So what we have to consider a conducting element dl of the loop as shown in the figure. The magnitude dB of the magnetic field due to dl is given by Biot law as dB is equals to mu naught I times dl cross r divided by 4 pi r cube. What we understand actually from this? See, from the value of r, we can calculate from Pythagoras theorem, which is comes under root x square plus r square. So, like we can write up as a like this, r square is equals to x square plus r square also. Now, since we know dl and r are perpendicular to each other, what is a dl? So dl is a basically elementary particle. So that particular element, a small element, that r will be the perpendicular into the nature, because if I just taken this particular thing in a zoom way, so that will be perpendicular. From this we can write up as a dv is equals to mu naught by 4 pi dl by x square plus r square. From figure we can calculate the value of a cos theta. That comes r divided by x square plus r square to the power half. Now, for the x, because we have we know that there will be two components of a figure. So that perpendicular will be divided or cancel out by the next one. But the one component which not be changed here, that is a dbx. So in the x-axis, we just taken a like horizontal component. And we know the horizontal component, there will be two components of that particular field. db sine theta, which is a cancel out, and db cos theta, which will be add up. So here db cos theta, the value of this, we just put the value for cos theta and get the equation for dbx, that is a mu naught by 4 pi dl r divided by x square plus r square to the power 3 by 2. Now, if I'm just taking this value for the x-axis, we just give the direction or give the command to the magnetic field that the current or the things will be in the I cap direction. So at the center of the loop, the value of x will be 0. That means point P exactly lies at the center. So the value of B naught will be mu naught by I, mu naught by 2 r I times capital I. So again we can write up as a, or we can pronounce it as a, like vector B naught is equals to mu naught by 2r or I cap, or mu naught by 2 I by r I cap. The magnetic field lines due to the circular wire from a closed loop as shown in this diagram. So the direction of magnetic field is given again for this and from the previous one, that is from right hand thumb rule. We are just now do some numerical question or some like conceptual questions so that we can clear this topic. Biot law asserts that magnetic field dB due to an dl element or element dl carrying a current, steady current, that is I, at point B at a distance small r from the current is dB is equals to what? Here we have these options. Correct option will be A. Next we have according to the Biot law, the magnetic field or the magnitude of magnetic field is directly proportional to. We have these options again. Directly proportional to. Here we have to ask again directly proportional to. In the formula of Biot law, that is the current and the length element. Third question we have in a Biot law, the direction is given by. Do remember and just quickly mark on the particular options. The correct answer for this question is option A, right hand scroll. There is no angle dependence in what particular thing? There is no angle dependency. So earlier we saw, if you remember, similarities and like differences of any two. So the correct answer for this question is a Coulombs law. I hope you understand the topic till this much. If you have any kind of a doubt, students, you can ask in the particular like chat section. Till that, take care everyone, and thank you for watching this video.